Welcome everyone. Just a quick introduction. Dan, the SingularityComputers PCB designer, is going to take you through some of the new RPM control features that we have on our latest PowerBoards and also some of our hubs.
In this video, we wanted to talk about our implementation of fan and pump speed control technology. This now can be found on some of our newer PowerBoards, like the Spectre 4, or the newly released active nodes like the Meganode and T-Control node. The idea was to separate the PWM speed control from the computer system and make it completely independent. With this implementation, you no longer need to set up fan curves in the BIOS and reboot the system multiple times until the speed response is appropriate for your workload and cooling setup. Also, you no longer need to redo the fan curves after a BIOS update, or if you change your motherboard or the fans. No software is needed either, so this tech is platform independent too. All you need to do is connect a temperature sensor to measure the coolant temperature and adjust the fan speed using the potentiometer down to your preferred minimum when the system is idle. The way this works is that the coolant temperature is monitored, and if it is below 25 degrees Celsius, then the fans and pumps will operate at the minimum speed set by the potentiometer. For the fans, this can be anything between 30% and 100%. For the pumps, between 50% and 100%. If the coolant temperature goes above 25 degrees Celsius, then the controller raises the PWM speed with it to increase airflow with the fans and water flow with the pump, both at the same time. The PWM speed increases linearly up to 100% when the coolant temperature reaches 45 degrees Celsius. We chose these minimum and maximum values for low noise operation at room temperature and idling, and to protect the coolant, the tubes, and the pump from high coolant temperatures at full system load. This system of control is unique in a sense that no matter what type of fan is used on the radiators, their speed will be adjusted until their cooling capacity matches the system's heat output. This PWM speed control implementation was designed with the aim to minimize user interaction and to make the initial setting up as simple as it can get. It is also worth mentioning that if there is no temperature sensor plugged in, then the controller operates the fans and pumps at a fixed PWM speed, which is set by the potentiometer. Here we have the Meganode on the left and the T-Control node on the right. The Meganode is powered by up to two PCIe 8-pin power connectors and has two PWM input headers, one for the fans and one for the pumps. Between the power connectors is the 2-pin temperature sensor header. For outputs, it supports up to 16 fans and 2 pumps. There are two PWM channels, pumps on the left and fans on the right side. The potentiometer sets the minimum speed for the channels independently of each other, while the switches change the PWM source between motherboard and temperature-based control for each channel separately. Grab a PCIe 8-pin power cable from your power supply and plug in one connector to one of the PCIe in headers for up to 150 watts of output power, or plug in two power cables for up to 300 watts of total output power on the Meganode. Then we connect our PWM controllable fan to the header labeled Fan Output 1 RPM. This header only reads the RPM from the connected fan. Now we can control the speed of the fan with the potentiometer from a maximum speed of 100% down to a minimum speed of 30%. Currently, we don't have an RPM reading in the BIOS until we connect a PWM linking cable to the motherboard. This linking cable allows the motherboard to read the RPM and send a PWM signal to the nodes. Plug one end into the fan in header on the node and the other end to any PWM header on the motherboard with RPM reading. In this case, we will use the main CPU fan header. Now we can see the speed of the fan and test out the potentiometer. This fan's maximum speed is about 1500 RPM, So when we turn the potentiometer down to 30%, the speed reading will be roughly 500 RPM. On the node, we can switch the PWM source to the motherboard easily, where we have set a custom speed of 30% in the BIOS. Let's change it to full speed now, and the fan will speed up to about 1500 RPM again. And if we go back to the custom 30%, the fan speed will follow that setting through the node. With the switch, we can change the PWM source at any time. The system does not need to be restarted. The speed can be changed even under a full system load on the spot. The pump PWM header works the same way, so we move the PWM linking cable to the pump in header and the fan to the pump out 1 RPM header to test this channel too. For this demonstration, we will keep using this fan to represent the pump. Now we control the pumps with the potentiometer on the left. For the pumps, the maximum speed is the same 100%, but the minimum speed is 50% to prevent coolant flow becoming too low for adequate circulation. The PWM source can be switched to the motherboard, where we can again test out various PWM settings the motherboard offers. The maximum and minimum speed available will depend on the motherboard's capabilities. We can change the PWM source on this channel too at any time. Now we swap over to the smaller T-control node. This design is powered directly from the motherboard PWM header, so plug the linking cable into the fan in header and the fan into the fan out 1 RPM header, since this header provides RPM reading. The speed control works exactly the same. The maximum speed is 100%, which is about 1500 RPM, and the minimum speed is 30%, which is roughly 500 RPM for this fan. We can switch the PWM source to the motherboard and have it control the fan speed, and the node will pass the motherboard PWM signal to the connected fans. For the next demonstration, we will plug everything back into the Meganode. These active nodes, just like our newest PowerBoards, can monitor the coolant or the air temperature and use that reading to adjust the speed of the connected fans and pumps independently of each other. To use this feature, we need to connect a standard 2-pin temperature sensor to the 2-pin header on the nodes with the label T. And it is located in between the 2 PCIe power connectors on the Meganode. At 25 degrees Celsius or below, the nodes will operate the fans and pumps at the minimum speed set by the potentiometer, which is currently 30%, resulting in 500 RPM. Let's put the temperature sensor in hot water to test the PWM speed response. As the sensor warms up with the coolant, it increases the PWM speed up to 100% above 45 degrees Celsius. This will happen slowly over time. Let's move to the T-control node and repeat the test. Plug in the temperature sensor to the 2-pin header labeled T on the node. The fan to fan out 1 RPM and the PWM linking cable to the header labeled fan in. Again, at 25 degrees Celsius or below, the PWM speed is set by the potentiometer, 30% in this case, and the fan will spin at 500 RPM. We submerge the sensor in hot water again, and as it slowly warms up with the coolant, the node then increases the PWM speed up to 100% above 45 degrees Celsius.
So this video is obviously for those who appreciate the in-depth information on how these things work, and this is only one aspect of the PowerBoard, the RPM control. It may sound a little complex when we lay it out in detail like this, but in practice it's more simple than the other methods that have been used so far, such as adjusting RPM curves in the BIOS, which involves going in and out of the BIOS many times to perfect your RPM curves if you really care about that. Because what is trying to be achieved here is a balance between the noise output and the temperature. And to be able to fine-tune that, you really have to put in some time listening to the noise output of the system, monitoring the temperatures. With this, you can adjust real time without the complexity of controllers, software, and BIOS control.